Okay, this is going to be the introduction to trigonometry. So when we're talking about trig, we're going to talk about sine, cosine, and tangent. Other ways to write sine, cosine, and tangent is sine, cosine, and tangent, so just the three letters. Okay, so whenever we're talking about this, we're talking about the angle. The angle always sits next to, the sine, cosine, or tangent. So they're talking about angle A. So all of these things are going to be perceived from angle A. Okay, so if I label this triangle, this is going to be my hypotenuse. And now from angle A, this is going to be adjacent, because adjacent means next to. And the thing opposite or across from is going to be this side here. So we would say this is opposite. Okay? So when I'm doing this, sine is the opposite over my hypotenuse. Okay, so O over H. So the thing that sits opposite of angle A is side A. The thing that's the hypotenuse is side C. Okay, cosine is adjacent over hypotenuse, so we could say A over H. So the thing that's adjacent to angle A is side B. The thing that is the hypotenuse is side C again. My last one, tangent, it is opposite over adjacent, so O over A. So the thing opposite to angle A is A. The thing adjacent to it is side B. So we talk about sides when we're doing these. The angles go in with the sine, cosine, and tangent there, and then the sides are on the other side. Okay, so a shortcut to remember it is called SOHCAHTOA. So this represents sine. This is my opposite, my hypotenuse. This represents cosine. This is going to be my adjacent in my hypotenuse. And then this represents tangent. So we had sine, cosine, and tangent. This represents my opposite and my adjacent. So the A's, O's, and H's are representative of the sides, and then we have the sine, cosine, and tangent. Okay, so if you look to the right here, we have the SOHCAHTOA. Okay, opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. So when we're doing them, okay, my first set we're coming from angle G. So I'm coming from this angle here, so I'm going to label my triangle. This is my hypotenuse. Okay, my side adjacent or next to. And then my side opposite or across from. Okay, sine, if I write SOHCAHTOA over here, so SOHCAHTOA, sine is opposite over my hypotenuse. So my opposite is 15, my hypotenuse is 17. Okay, cosine is adjacent over hypotenuse. So the thing that's adjacent is 8, and my hypotenuse is 17 again. Tangent is opposite over adjacent. So the thing that's opposite to G is 15, adjacent is 8. Okay, my next one, we're coming from angle T, so I need to erase all these because it could be different. So angle T, so we still have this being my hypotenuse. This is adjacent because it's the thing that sits next to it, and then opposite or across from it is right here. So sine, we have opposite over hypotenuse, so the thing that's opposite of angle T is 8. The hypotenuse is 17. Cosine, we have adjacent, so 15 over hypotenuse, 17. And then tangent, it is opposite over adjacent, so we have opposite, which is 8, and adjacent, which is 15. Okay, so this one we're coming from angle D. This is my hypotenuse. This is my opposite. And this is my adjacent because it sits next to, but I don't have this length here, okay? So if I have a right triangle, I can use Pythagorean theorem to find that missing length. So this represents C because it's my hypotenuse, so we got 5 squared equals 3 squared plus B squared. 5 squared is 25, 3 squared is 9. If I subtract 9 from both sides, 25 minus 9 gets me 16. Opposite of squaring is square rooting. So I got B is equal to 4, so that means this length right here is 4. So now I can go ahead and start. So sine, if I write SOHCAHTOA up here again so I can remember what they all are, SOHCAHTOA. Sine is opposite over my hypotenuse, so opposite of angle D is 4. Hypotenuse is 5. Cosine is adjacent over hypotenuse. And then tangent is my opposite over my adjacent. Okay, so my next one, it looks like I'm missing my c this time. So I got 3 squared plus 3 squared equals c squared, which is 9 plus 9 equals c squared. So c squared equals 18. Opposite of squaring is square rooting. So c is going to equal 3 square root 2. So that's what this represents. Okay, so if I'm doing, we're coming from angle D this time. So if I label, this is my adjacent, this is my hypotenuse, and this is my opposite because it sits across from it. So if I'm doing sine, we have opposite over my hypotenuse. Okay, but I need to simplify this because I can't have that square root on the bottom. So I can multiply by the square root of 2 over the square root of 2, or I can just type in my calculator 3 divided by 3 square root 2, which gets me square root 2. Okay, my next one is cosine. Cosine is adjacent over hypotenuse, so my adjacent is 3, hypotenuse is 3 square root 2, so I need to do that again, get the exact same answer. My tangent is opposite, so 3 over my adjacent, 3 divided by 3 is 1. Okay. For our last one, we're coming from angle Z. Looks like I need to find this right here. Okay, I already have my c, so I got 8 squared because that's my hypotenuse. 4 squared plus b squared. 8 squared is 64. That's 16. We're solving for b, so we need to subtract 16. So 64 minus 16 gets me 48. Opposite of squaring is square rooting. Square root of 48 gets me 4 square root 3, so this represents 4 square root 3. Okay, so we're coming from angle Z, so if I label my triangle here, this is going to be my adjacent because it's next to it, hypotenuse because it's across from my right angle, and my opposite because it sits across from it. Okay, so if I write SOHCAHTOA here, doa. Sine is opposite, so 4 over my hypotenuse, 8, which simplifies to 1/2. Cosine is my adjacent, so 4 square root 3 over my hypotenuse, which is 8. I'm going to type that in my calculator to see what it simplifies to, and it simplifies to square root of 3 over 2. And then tangent is my opposite, so 4 over my adjacent. So I'm going to type that in my calculator to get the square root of 3.